This is Patrick Lestrange here from York College, here at NOAA, the National Oceanic and Atmospheric Administration. And behind me we have the front ridge of the Rocky Mountains.
This is Kiersten DeBlaker, also from York College, and we are here to talk to Pieter Tans about climate service, the Keeling curve, and the global monitoring of NOAA.
Man's influence on the planet has become overwhelming, and this hasn't sunk in with a lot of people. So greenhouse gases and climate change is one manifestation of that. There's many other manifestations. We are also the cause of species extinction. We are changing ecosystems as we speak. We are wasting, if you will, chemicals into the environment that we don't know the effect of. You know, certain chemicals may interfere with our immune system, or the endocrine system, hormones. We don't know this, but we may actually be decreasing what the next generations inherit from us. So every year CO2 is higher. Ever since Keeling started these measurements in 1958, every single year it has gone up. The rate of increase varies a little bit. One year it goes up more than another. And that has to do with plants. So every summer, in the northern hemisphere certainly, plants take up more CO2 than release from respiration. So you can see in the northern hemisphere especially that CO2 goes down until about September, mid-September or so, and then it starts going up because then photosynthesis starts to slow down, and respiration is still working at full tilt. And at that point CO2 increases in the atmosphere, and it increases throughout the winter until spring starts, and then it goes down again. Emissions per capita in the US have been fairly constant, actually. So the global growth in emissions is now coming from China and India, primarily China at this point. Because per capita emissions in China are twice what they are in India. They use half of the energy that the average Chinese person uses. Our emissions are 4 times per capita, 4 times those of China. You know, there's plenty of reason for emissions to continue to go up. Well, emission standards haven't had much of an effect, I think, except for cars. And that was, and then during the Carter administration, the fuel efficiency standards were adopted. You know, mileage standards for the U.S. car fleet. The fact that we didn't keep pushing on that, one of the results is that we're now importing. The majority of the oil that we use is imported. One of NOAA's goals is to produce better predictions, not only of the weather of the coming week, but also climate change. That's one of it. So understand climate change and therefore predict it better. So we do 2 things really. We have a very accurate measurement network globally, so we keep track in a very accurate, well-documented manner. Everything is, all the data are very carefully calibrated. That's one thing. The second thing is that we not only keep track of the increase, but we keep track of small differences in space and time. So the northern hemisphere is slightly higher in CO2 than the southern hemisphere. Most greenhouse gases are slightly higher in the northern hemisphere than in the southern hemisphere. Why? Because they're emitted in the northern hemisphere. But COP, the Conference of Parties, NOAA mostly, I think, wants to show what we're doing. Wants to let whoever is attending the meeting, and the press in particular, they want to let them know, hey, this is what we're doing.
Right.
So before Keeling started his CO2 measurements, we didn't really know how much the CO2 concentration in the atmosphere was. It could be anywhere between 200 and 500 ppm. We didn't know, because people had measured CO2 already in the 19th century, and they got a tremendous range of answers. So they had anywhere between 200 and 500 ppm, which was actually not a bad measurement. because they were still trying to find out how much there was in the first place. And they couldn't really see the seasonal cycle. They didn't know what the patterns were. And so Keeling started, and he had two major innovations. The first one is very accurate calibration with reference mixtures of CO2 and air, which he made himself. And he had a way to make an absolute determination of it. The other innovation was a continuous analyzer measured in infrared. He used infrared absorption. The analyzer wasn't all that stable. So then he used these carefully controlled reference gases to control fluctuations in his instrument. And we still do that. And so when he did that, he saw for the first time the magnitude of the seasonal cycle. So he really proved there was a seasonal cycle. And the phase made sense because he knew about the growing season and the winter, the differences between those. And he saw that after 1 year of measurements, he saw the increase in CO2. So it was increasing in the early days on average 0.7 ppm per year. So we saw the seasonal cycle in the first year, and he saw it again in the second year, but everything was higher in the first year by about 1 ppm. So after 2 years, he already had seen the increase, which is now not 0.7 ppm per year, but 2 ppm per year. Yeah. So it was really revolutionary.